right, gang. Hypothesis testing. I think the last video was all over the place. Again, because there's just so much new information uh, to try to understand. So let's just dive into a couple of examples. So first of all, I just want to start out and focus on hypothesis testing for proportions. So our null and alternative hypotheses will look like this. We will have P equals some value. Whatever value is there must go here. You'll find out in StatCrunch that it doesn't give you a choice of changing this, because you can't, you should. And then we have to choose the alternative, the sign, the inequality, that best fits the statement of the problem. The second thing we do is we state alpha, which again is the level of significance of our test, and we evaluate our sample data. The third thing we do is we calculate our critical value. The fourth thing is we calculate our test statistic. And the fifth thing is we make a decision. All right, so let's start out with example number one. Let's say we are testing the claim that percentage is 72%, so P equal 0.72, and we would like to test that the P is less than 0.72. We want to test at 0.05, and from our sample, we found out that 68% of 1,200 people will have whatever characteristic that we're measuring. Now, because we need this P hat in terms of X over N, I have to take 0.68 times 1,200 and find that that's 816 out of the 1,200 people. So I need this particular count. Now, many times when you multiply this percentage times the N, you'll get like, 815.257, get a decimal. This always must be as an integer because we're talking about a count. You can't have 815.7 people out of 1,200. It has to be round up to 816. In this case, we didn't have to round up because 68% of 1,200 is 816. But typically that won't be the way it is. The next thing we have to do is we have to set up our critical region. All right, so this part down here is the reject region, and this part right here is the fail to reject region. Our decision is always on the null hypothesis. Reject the null or fail to reject the null. Now, I get my critical value at negative 1.645. I have 5% of my region down here because I have an alpha level of 0.05. The way I got that was very simple. Go to normal. I need less than, and I need that area down there to be 0.05. And I see I get negative 1.645. The next thing I do is I evaluate my test statistic. So that's p hat, so 0.68 I got from my sample, 0.72, the claim in the population, or I'm sorry, the claim in the null hypothesis. And then the standard error is 0.72 times 1 minus 0.72, which is 0.28, divided by the sample size. When I put that in my calculator, and I just did that, so let me show it to you. All right, so 0.68 minus 0.72 is the right problem, right? Yeah. And hit enter, and I get negative 3.086. So that test statistic is way down here, which falls in my reject region. So my decision is to reject H sub O. Example number two. Let's say we're testing that the population proportion is 60%. Again, always state this as a decimal. And we would like to test that the percentage is not 60%. We are testing in this test at alpha equal 0.01. And let's say that in our sample, we have 278 out of the 421 that were sampled that have whatever attribute or characteristic that we are measuring. So the next thing I have to do is set up my critical regions. Again, this would be a reject region, this would be a reject region, and that would be a fail to reject region. Why do we have two reject regions? Because a not equal to alternative hypothesis results in a two-tail test, two tails of rejection. Now, we need to find these values, okay? So alpha over 2. So alpha is 0.01. So I need the upper area to be 0.0005. So my upper tail is 2.576. And of course, my lower tail is negative 2.576. These are z values. Remember, z values are centered at 1. We have complete symmetry. So if we have 0.005 of the area above, we have 0.005 of the area below. We have to have symmetry here. So work this out. Always remember that that needs to go in parentheses so you don't get an order of operations issue. And we get a test statistic of 2.51. 2.51 falls right there, and it's just slightly below the critical value. Nevertheless, it's enough below the critical value to give our decision as failed to reject the null hypothesis. Now, you probably know what's coming next, right? Okay. There's a way to do this on StatCrunch, as you would expect. Go to Stat, go to Proportion Statistics, go to One Sample, and go to With Summary. First one, number of successes. Notice how I can't put in 68% there. I have to put the number of successes, which is 816. That always has to be a count. My total number, and again, I can't put 816.5 or point, it has to be a count, an integer. 5, 6, 7 has to be a count. Number 1200. Hypothesis testing, H sub OP equal. Notice it puts 0.72 there and doesn't allow you to change it because you shouldn't. And then I choose the inequality that suits the problem. Now I want to show the critical value, and my alpha over here is 0.05, so that's the value I put right there. When I compute, notice that I get this. My z-stat, which is my test statistic, is negative 3.086, which is that right there. And my critical z is negative 1.645, which I get right there. The output on StatCrunch doesn't tell you the decision, reject or fail to reject. So you have to interpret that by just seeing that since the z statistic, the test statistic is less than the z critical, then you would fail to reject. What about this problem? Now, what I would recommend you do is I would recommend you pause the video, jump on StatCrunch, and see if you can work this. All right, pretend you paused me, pretend I'm back, and let's go to One Sample with Summary. Number of successes are going to be 278 out of 421. My P is 0.60, and I need not equal to, so that's what's selected. I want my critical value, but here you'll notice that my level of significance is 0.01. compute. Let's focus on what we need to focus on. The Z-stat 2.526. Look familiar? Off a little bit due to rounding. The Z-critical 2.57, not off at all. And again, it doesn't, the output doesn't tell us what decision that we make, but we need to know that if the if the test statistic is less than, or at least it's in the range of the fail to reject area, then we fail to reject. All right. So hopefully that made things we still have a long way to go. We have a lot. We have to talk about error. You know, we have to talk about what's this alpha really telling us. Turns out it's actually the probability of a type 1 error. We still have to dive into mean problems. We got to talk about power analysis. We have to talk about a p-value approach. You might notice that I was kind of sly, right? When I closed that part down. Well, that p-value actually turns out to be pretty super important. Um, and but I don't want you to think about that just yet. All right, take care.